Let's jump right into this explainer and demystify the absolute magic, both mechanical and electronic, that makes steering your car feel so incredibly effortless. If you've ever tried to yank the wheel of a parked car with a dead engine, you know exactly how much raw physical force it takes to scrub those heavy rubber tires across the pavement. It's an upper body workout for sure. So today, we're exploring the fascinating engineering that finally saved us from all that heavy lifting. We're going to look at exactly how the automotive industry completely shifted gears, moving from brute force hydraulics to these highly intelligent electric systems.
Now, driving enthusiasts have some pretty strong feelings about losing the natural connected road feel of hydraulic steering. For decades, it was the absolute gold standard for how a car should drive. So why did automakers abandon it? Well, as we'll see today, there are some massive realities around engineering, packaging, and efficiency that drove a really rapid industry-wide shift. We basically moved away from messy fluids and pumps and ran straight into the arms of motors and microchips.
All right, here's our roadmap for today's journey. We'll start with the power steering revolution, take a look inside hydraulic systems, explore the big shift to electric, see exactly how that electric steering works, weigh the trade-offs in road feel, and finally, cover how to spot power steering failures.
Part 1. The power steering revolution, from heavy metal to high-tech.
Way back before 1951, steering a massive front-engine sedan required some serious muscle. You literally felt the entire weight of the car on those front wheels. But then, in 1951, the Chrysler Imperial totally changed the game by introducing a hydraulic power-assisted system. And that hydraulic brawn? It ruled the roads for decades. It wasn't until 1991 that the Acura NSX debuted electric power steering. At the time, it was mostly just a neat novelty, a clever way to save space and weight in a high-end sports car. Fast forward to 2014, though, and vehicles like the Infiniti Q50 really signaled that electric power steering, or EPS, was the new mainstream standard. The mechanical era was officially stepping aside for electric brains.
Let's get into Part 2, Inside Hydraulic Steering Systems, the Mechanical Era. So check out the intricate mechanical choreography of a standard power rack and pinion setup. In a classic hydraulic system, your car's engine actually drives a pump, usually hooked up with a belt, that is constantly pressurizing hydraulic power steering fluid. That highly pressurized fluid is forced through those lines up at the top, right down into the gear housing. It literally provides the juice that pushes against a hydraulic piston inside that long horizontal cylinder, giving you the assist you need to move the tie rods and turn the wheels. But, it begs the question, how does it actually know when to push? To answer that, we really need to look right at the center of the steering gear, specifically the pinion shaft and the rotary control valve. Honestly, this internal movement is a lot like a high-end Swiss watch. Tucked inside that input shaft is a super clever part called a torsion bar. When you're just cruising straight down the road, the valve stays perfectly centered, and the hydraulic fluid just happily circulates right back to the reservoir. No big deal. But the very instant you turn the steering wheel, the friction of your tires down on the pavement causes the pinion to resist turning. And that resistance? It causes that tiny elastic torsion bar to physically twist.
So the absolute crucial takeaway here is this elegant three-step sequence. First, you have that torsion bar twisting, just a tiny fraction. Second, that twist physically misaligns some little holes in the rotary valve, which instantly redirects all that high-pressure fluid. And third, the fluid just floods right into one side of the power chamber, pushing the piston left or right to give you that much-needed steering assist. Because this whole process relies on continuous fluid pressure that responds instantly to the physical twisting of metal, you get a really smooth, highly responsive assist. It's this exact mechanical feedback loop that makes hydraulic steering feel so incredibly alive and connected to the road.
Okay, moving on to Part 3, the shift to electric, chasing efficiency.
Now, if hydraulic steering feels so great, why did we ever get rid of it? Well, its biggest flaw is that the hydraulic pump is driven directly by the engine, and it is running all the time. Even if you're just cruising perfectly straight down an interstate, needing absolutely zero steering assist, that pump is still spinning. It's a continuous parasitic drag on the engine. By simply stripping out that constantly running pump and moving to a system that only draws power when you actively turn the wheel, boom, automakers instantly improved fuel economy. In fact, according to BMW, making this switch yields fuel efficiency gains of as much as 3%.
And I know 3% might not sound like a lot, but it is absolutely massive when you consider corporate average fuel economy or CAFE standards. If an automaker fails to meet these strict federal mandates, it can cost them literally billions of dollars in fines. Billions. Plus, think about it. Hydraulic systems are heavy, They require messy fluids, and they rely on belts and hoses that are basically guaranteed to wear out over time. So ditching this heavy, power-sapping mechanical system for a lighter, on-demand electric setup, that became an absolute matter of survival for manufacturers trying to avoid the federal penalty box.
Which brings us to part 4, how electric steering works, sensors and software.
The sequence for electric power steering, EPS, is just incredibly elegant and highly efficient. Instead of a pump, when you turn the wheel, a torque sensor measures exactly how hard you are trying to turn it. At the same time, a steering angle sensor notes exactly where the wheel is pointed. All that data gets fired off to the electronic control unit, the ECU, which also factors in how fast the car is moving. Then the computer commands an electric motor to apply the precise amount of physical assist you need. Often, this motor uses a toothed rubber belt to drive a ball screw mechanism, which physically pushes the steering rack. The genius here is that it only uses energy in the exact millisecond you ask for it.
And from a design perspective, the packaging flexibility this offers is just phenomenal. Automakers can stick these electric motors in completely different spots depending on the vehicle they're building. You've got column assist, which actually puts the motor right inside the cabin on the steering column, which is great for smaller, more affordable cars. Then there's rack assist, where the motor drives the steering rack directly. That setup gives you much stronger precision, which is perfect for heavier vehicles. And finally, pinion assist, where the motor helps out right near the gear itself. By completely ripping out that old network of hydraulic pipes and fluid reservoirs, engineers freed up so much underhood space for other components, a real game changer.
Part 5. Road feel and trade-offs. Brawn versus brains.
I absolutely love this analogy from the source material. Think of a hydraulic system like the power lifter. It's this constant, sturdy spotter who is always right there holding the weight, giving you incredibly natural, continuous feedback. But of course, they're draining your engine's energy the whole time. The electric system, on the other hand, is like the smart machine. It's a crisp, highly efficient piece of gym equipment that senses your effort and adds exactly the assistance you program it for, but only when you ask. Now, because EPS relies on sensors and software, manufacturers can literally program it to filter out harsh road vibrations for a smoother ride. But there's a catch. A bad software calibration can make the steering feel totally numb or artificial, basically isolating your hands from what's actually happening down on the road surface.
But listen, regardless of where you stand on the steering feedback debate, there is one undeniable advantage to electric steering. It is the mandatory gateway for all modern safety features. Think about it. A traditional hydraulic system just can't easily steer the car on its own. EPS, however, talks seamlessly with the car's main computer, and that enables all those advanced driver assistance systems we're getting used to. Things like lane keeping assist, automated self-parking, and even active crosswind stabilization to keep you steady on the highway. Plus, the National Highway Traffic Safety Administration is actually mandating automated emergency braking by 2029. So EPS isn't just a trick to boost fuel economy, it is literally the foundational tech making our self-driving future a reality.
All right, let's wrap things up with part 6, spotting power steering failures. What to watch for.
Now, this is practically important. If a classic hydraulic system fails, let's say the pump finally wears out or a high-pressure hose bursts, you're usually going to get some heads up. You'll hear these awful whining or groaning noises when you turn the wheel all the way, or maybe you'll spot some fluid dripping on your driveway, or see an oily mess on the radiator. The steering will probably start to feel kind of heavy or notchy. But with electric power steering, a failure is often totally silent and very sudden. You might just lose your steering assist completely out of nowhere, accompanied by a sudden fault code popping up on your dashboard. Diagnosing EPS is a whole different ballgame too. You need electronic scanners to dive into module communications and sensor data on top of the usual mechanical checks. But here is the good news. If either system fails, whether a hydraulic belt snaps or an electric motor just gives up the ghost, your car does not become impossible to steer. That physical mechanical linkage to the wheels is still there. You just lose the power part of power steering, which means, yep, you're back to relying on your own raw muscle to force that wheel to turn.
And that brings us to the end of our journey through the steering rack. It really is the ultimate automotive debate, isn't it? Do you prefer the mechanical, connected brawn of the hydraulic past, or the incredibly adaptive, efficient digital brains of the electric future? While purists might always mourn the loss of perfectly tactile road feedback, the massive gains we've seen in fuel efficiency, packaging, and life-saving automated safety features make the electric revolution an absolute engineering triumph. So the next time you effortlessly spin the wheel with one hand to parallel park, just take a quick second to think about all those hidden sensors, electric motors, and thousands of lines of code that are doing the heavy lifting for you. It really begs the question, as software continues to take over more and more of the vehicle, will we eventually miss the days when we had to do the heavy lifting ourselves? Thanks so much for joining me on this explainer, and we'll see you next time.